Finally, we have that crowd favorite, the open top box, where we cut a square out of each corner and we come up with the volume of the box. That's supposed to be a V. There's a little extra little mark there. It looks like an upside down A, but that's a V. So what is the volume in terms of x? Well, if you take 24, so you take 24 and you take x away from one end and x away from the other end, then what's left over is 24 minus 2x. So you've taken x away from each end right here, and you're left with this little space here, 24 minus x, which is 24 minus 2x. That would be, if we fold up the sides, these squares that we cut out, if you fold them up, the x is the height, and then since this is a square piece of whatever it is, cardboard or something, then each side of that open top box has length 24 minus 2x. So it's as straightforward as that. So as long as you can visualize what's going on, then getting that number right there, the length of the length of each side of the base of that open top box, you can know again that volume is length times width times height. So knowing that, you just multiply all three of these together to get your volume function. We could have written this as x times 24 minus 2x quantity squared. We could do that as well. Either one is okay. All right. So once we have that, let's say we're using Desmos, and it's a very simple thing to do. As long as you are able to, in Desmos you would write v of x. Okay, so v of x on the graphing calculator, it's the name of the function is already defined, but in Desmos you would type in v of x equals, and then you just type it in, x times 24 minus 2x, and we can do it the fancy way and square that. All right, so that's our function. Okay, now v of 3 then would be 3 times, and you can use Desmos for this. Okay, this is in essence what Desmos is doing. It's replacing x with 3, right? So if x is 3, then you put a 3 in place of the x. And we can do that by evaluating in Desmos. You could say, well, if you named it v of x, then you would just type v of 3, and it would give you the right value. In using a graphing calculator, you would just do y1 of 3, and you would get 972. And since this problem does have meaning, let's see, these are inches, right? So that would be cubic inches. Volume is always in terms of 3 dimensions. And then we could also evaluate the function, the volume function, when x is equal to 10. So we would want to replace x with 10. So 24 minus 2 times 10. And you can just write it like that, and then just type it into Desmos, just like that. Do v of 10, and as soon as you type in the 10, it should just pop up as 160. And then what x yields maximum volume? Well, think about how big x could be. X can't be smaller than 0, and it can't be bigger than, you can't take more than 12 away from one side. So let's let 12 be the maximum x, and then we know the volume can't be negative, and we're not really sure, but we know that the numbers get up here pretty big. So 972 if x is 3. So let's just to be safe, let's put 2500 for the y max. And there we have our graph, and we know that the maximum volume is going to occur at that maximum spot. So let's say 1, and what did we say, 12? So 11, and then 5. Let's just find that maximum value, and then the graph that you would want to write out would look something like that. Doesn't matter how fancy it is, just make sure it has a high point, and that you label the high point, 4, 1024. And so what x yields the maximum volume? We would say 4 inches. Okay, 4 inches, and that is the answer to that one, because the maximum volume is there. That's the volume. So this is the volume in terms of x. This is x. There's your x. There's your v of x right there. Okay, so when x is 4, the volume is at its maximum because you can see it. It's at the high point.